Okay, we're going to practice some freezing point depression and boiling point elevation problems. First one, determine the new freezing point of water if 37.6 grams of glucose, that's a non-electrolyte, is added to 253 grams of water. First thing I need to do is take my 37.6 grams of sucrose and I need to convert that into moles. I'm going to do that using the conversion factor right here. Cancel that out, that leaves me with 0.110 moles of sucrose. Now what I need to do is I need to figure out the molality of this solution. So I have the number of moles of solute. Now I need to get the number of kilograms of solvent. I have 253 grams of water. That's going to work out to be 0.253 kilograms. Take that 0.110 divided by that. That's going to give me a final solution for this of 0.435 mole solution of sucrose. Now I'm going to take that and I'm going to plug it into my equation. So I have my change in temperature, and remember this is the freezing point depression. I need to first plug in the K sub F. Remember that is going to be my constant for water. That's 1.86 degrees Celsius per unit of mole solution. Now I'm going to plug in the molality of it, 0.435, so that came from right up here. Now I need to plug that in to my dissociation factor. For this sucrose, that's going to be 1 because it's a non-ionic solution. It's not going to separate out. Doing all those calculations there, that's going to give me 0.809 degrees Celsius. Now remember, this is not the absolute temperature, this is the change in the temperature. If the normal freezing point is 0.0 degrees Celsius, now I need to subtract it from here since I'm doing freezing point depression. That's going to give me a final new freezing point of negative 0.809 degrees Celsius. What is the new freezing point of 2,300 grams of acetic acid or vinegar when 94.3 grams of sodium chloride are dissolved in it? So I'm going to take my 94.3 grams of sodium chloride and I'm going to first convert that to the number of moles of sodium chloride. Canceling that out gives me 1.612 moles of sodium chloride. Now I'm going to take that and I'm going to divide that by my mass of the solvent. 2,300 grams works out to be 2.3 kilograms of solvent. Now I'm going to plug that in here and calculate the molality. Moles of solute divided by kilograms of solvent. That's going to work out to be 0.701 mole sodium chloride. I'm going to plug in my K sub F for acetic acid, which is 3.9 degrees Celsius per mole unit solution. So 3.9 times the molality, 0.701, and the dissociation factor for sodium chloride is going to be 2, because that sodium chloride is going to break up into two ions, the sodium cation and the chlorine anion. So taking this all, multiplying that all together, I get 5.47 degrees Celsius. Remember, that's the change in the freezing point. My original freezing point for acetic acid, vinegar, is 16.6 degrees. Now I need to subtract 5.47 from that. So that's going to give me a new freezing point of 11.13 degrees Celsius is the new freezing point. Now we're going to do a boiling point one. So find the new boiling point of water when 354 grams of magnesium bromide are dissolved in this much water here. Same as before, I'm going to essentially figure out how many moles I have of magnesium bromide. Cancel that out. That's going to work out to be 1.92 moles of magnesium bromide. I'm going to take that and I'm going to divide that by the kilograms of solvent. 5,044 works out to be 5.044 kilograms of water that I have there. Doing that math there gives me 0.38 mole solution of magnesium bromide. Now, same as before, in this case, I'm not going to use the K sub F, I'm going to use the K sub B. Slightly different number, the exact same idea though. So 0.51 degrees Celsius per mole unit solution times my molality, which is 0.38. My dissociation factor is going to be 3 for magnesium bromide, because remember, I'm going to get 1 cation of magnesium plus 2 anions of bromide. So I'm going to get 3 of them in solution. So I'm going to multiply that by 3. That's going to work out to be a change in the boiling point of 0.581. Remember, not the new boiling point, the change in it. My original boiling point for water is 100 degrees Celsius. Now I'm going to add to my original boiling point 0.581. This is going to give me a final boiling point of 100.581 degrees Celsius. That is the new boiling point after I add that much solute. Now we're going to determine the boiling point if 79.45 grams of sodium nitrate are dissolved in 733.2 grams of water. As before, I'm going to take that and I'm going to convert that into the number of moles I have of sodium nitrate. Take that, divide that by my number of kilograms of water. 733.2 works out to be 0.733 kilograms. Take that, I get 1.28 mole solution of sodium nitrate. My K sub B for water is going to be 0.51. Going to multiply that by the mole solution of 1.28, and the dissociation factor for sodium nitrate is going to be 2. That's going to break apart to be a sodium cation and the nitrate polyatomic anion there. Multiplying that by 2, that's going to work out to be 1.31 degrees Celsius. That's my change in the boiling point. The original boiling point for water is 100. I'm going to now add 1.31 to that for a new boiling point of 101.31 degrees Celsius. Now I'm going to calculate both the new boiling and freezing point. So same idea as we've seen before here. I need to figure out the molality of the solution that I have. 88.34 grams of potassium chloride. That's going to work out to be 1.18 moles of potassium chloride. Take that and divide that by 432 grams of water. That's going to work out to be 0.432 kilograms. Dividing one by the other is going to give me 2.73 moles solution of potassium chloride. So my change in freezing is going to be my K sub F, 1.86. Make sure you don't mix up the K sub F and K sub B. My molality is going to be 2.73. The dissociation factor is going to be 2 for potassium chloride. Putting those all together is going to give me a change in the freezing point of 10.16 degrees Celsius. Now let's do the change in boiling point. I'm going to use a different one. I'm going to use K sub B 0.51, same molality as before, 2.73, same dissociation factor as before, 2 for the one cation and one anion. So that's my freezing point up there. That one below is going to be my boiling point. Now I'm going to either subtract or add to the original one. It froze originally at 0. Subtract 10.16, this one is now going to freeze at negative 10.16. The original boiling point was of course 100 degrees, and I'm going to add to that. So the original boiling point, 100 plus 2.78, is going to work out to be 102.78 degrees Celsius. Last one, what is the new freezing and boiling point of 45 grams of sucrose and 233 grams of phenol? So I'm going to take my sucrose and I'm going to work that out to be, that's going to be 0.132 moles of sucrose. Take that, divide that by my kilograms of solvent, so that's 233 grams or 0.233 kilograms. That's going to work out to give me a molar concentration of 0.567. So my change in freezing is going to be the K sub F, so 7.4, which I got from above. The molality is going to be 0.567 mole, and the dissociation factor for sucrose is going to be 1. It is a non-electrolyte. It doesn't dissociate. Working that all out, that's going to give me a change in freezing of 4.2 degrees. K sub B is going to be 3.6, same molality solution before, same dissociation factor I had before. That's going to give me a change in the boiling point of 2.04 degrees. So the top one is the freezing, the bottom one is going to be my boiling point of that. So my original freezing point for phenol is 40.9 degrees Celsius. Subtract 4.20 and I'm getting it at 36.7 degrees Celsius. My original boiling point was 181.8. I'm going to add to that now. I'm going to add 2.04. That's going to give you 183.84 degrees Celsius for a new boiling point.